volume of the second cylinder that the water from the first was poured into. Pi in this side is 22/7 times the R for the first cylinder. Remember that I said that the diameter is 80 millimeters. That means the radius will be 40, half of the diameter. 40/1 times the height is the depth of water in it, 125. So we have 125/1. It's going to be equal to the same 22/5/7 times the radius. Remember they told you that this water was turned into another cylindrical beaker of diameter 100 millimeters. That means the radius is 50. So we're going to have 50 squared all/1 times the height, the depth of the water in the new beaker. So the height is what they're asking for. So we have h/1. By the time you finish multiplying out, if you find the value of h, this value of h will answer question number A, that is asking for the depth of water in the new beaker. Now we have 40 times 40, then times 125 times 22. It's giving us, now let's divide out, divided by 7, so that we can manage our space. So we have 628,571.4286. It's now equal to, let's multiply out this side, 50 times 50 times 22 is equal to, we have then divided by 7. So this time we are going to have 7,857.1429 in 4 decimal places, h, because the whole numerator will multiply this before it will be divided by 7. So if you want to find the value of h, the value of h is going to be all these things divided by all these things. That is dividing both sides of the equation by all this. It's giving us 79.9999 reoccurring, which is approximately 80 millimeters. That is the height of the beaker the water from the cylinder was poured into. Question number B. Question number B is synonymous to question number A, because both the burette and the beaker, they are all cylindrical objects, and the formula for finding their volumes are the same thing. So in this case, it is going to be the same thing, that pi r squared h for the cylinder is equal to pi r squared h for the burette now, because the same water was poured into the burette now, unlike in A, it was poured into a beaker, all of them having a cylindrical look. Okay, to make this shorter, you can remove pi and remove pi, since they are found in both sides. So now have that r squared h is equal to r squared h. Now the radius of the first was 40. That means we are going to have 40 squared times the height 125 millimeters is equal to the radius is what they're asking for in B. So write r squared times the height. They said that the height, the water there is 360 millimeters. So we are going to use 360 to substitute the height. So when you multiply out this, you can find your arrow squared. And when you find arrow squared, the square root of the other side will now give you the value of r. Now let's multiply out. 40 times 40 is the meaning of 40 squared. Then times 125 is giving us 200,000. So we have 200,000 is equal to arrow squared. Okay, arrow squared times 360 will give you 360 arrow squared. Now divide both sides by 360 so as to get arrow squared. So we're going to continue here. Find out that arrow squared is going to be 200,000 divided by 360. Let's see what it will give us. 200,000 divided by 360. It's giving me 555 point. That means arrow squared is 555.55555 we are calling. So let's take 0.6. If r squared is 555.6, only r is going to be the square root of 555.6. And it's going to give us, it's giving me 23.5712 in 4 decimal places. We are finding r, so it's going to be in millimeters. And that has answered question number B of our first question on change of shape under our further mensuration topic. Question number 2 on change of shape says the two solids shown, these two solids have equal volumes. Okay? That's one of three, okay, the one of three discs or 3 disc layers has the discs of 2 cm, 4 cm and 6 cm in diameter. That means this one is 2 cm, this one is 4 cm and this one is 6 cm in diameter. Okay, while they are 1 cm thick each. 1 cm thick each. That means their height is 1 cm. That's another trick of the examiner. Instead of saying that they have height of 1 cm, they are not telling you that they have thickness of 1 cm. It's a trick. Don't mind them, yeah? Okay, then I said the other one is a cylindrical tube of diameter 2 cm. That means this one has 2 cm diameter. We are now asked to calculate the height of the tube, the height of this tube. It's very simple. This other one is made up of 3 sets of cylinder. 1, 2, 3. Since they said this and this have equal volume, that means the volume of the first cylinder here plus the second cylinder plus the third cylinder is equal to the volume of this one. That means we're going to have pi r squared h for the first one in that solid plus another pi r squared h plus the third pi r squared h is equal to pi r squared h of the cylinder. It's a very simple thing. Here we have 22. In all this, to make it shorter, we can cancel the pi's because they are common in all of them. So we now have r squared h plus r squared h plus r squared h is equal to r squared h. You will still get the same answer for the h of the cylinder, the height of the cylinder. Now, r squared for the first cylinder. Remember, he said that they have diameters of 2, 4, and 6. The first one that had diameter of 2, that means its radius is 1. So here we have 1 squared times the h is 1 cm for all of them. So we have 1 squared times 1 plus the second one has diameter of 4. That means radius of 2. So here we have 2 squared times 1 because the heights are the same thing, 1 cm. Then plus the third one has diameter of 6 cm. That means 3 squared times 1, which is their common thickness, which is equivalent to their height. Is now equal to, they said that this cylinder, which has the same volume with that, has diameter of 2 cm. That means we have 1 as its radius squared, then times height, which you are looking for. 1 squared is 1 times 1 will give you 1, plus 2 squared is 4 times 1 will give you 4, plus 3 squared is 9 times 1 will give you 9, is equal to 1h. 1h is 1 squared, which is 1 times h will give you 1h. You can just have it that this means h. So by the time you add 1 plus 4, 5 plus 9, which is 14, that means h, which the question is asking for, is 14 centimeters. And that has answered that question. You can see how easy the question is. But when you are looking at it from the question arena, it will be as if it is a very, very big something. Question number 3 says that 3 spherical iron balls of red dye. Red dye is the plural of radius. 3 cm, 4 cm, and 5 cm. That means the 3 different spherical iron balls have radius each of 3 cm, 4 cm, and 5 cm. The question said that they are melted and cast into another spherical iron ball, maybe a bigger one now. They were to calculate the radius of the latter iron ball. It's a very simple thing. The volume of the 3 melted spherical iron balls is equal to the volume of the latter spherical iron ball where the melted 3 was poured into. When you equate the sum of the volumes of the 3 melted to the volume of the one they were poured into, from there you can find the radius of the one they were poured into. The formula to find the volume of any sphere is 4 all over 3 pi r cube. So we are going to sum up 4 all over 3 pi r cube and equate it to 4 all over 3 pi r cube. What I mean is this. We are going to have 4 all over 3 pi r cube for the first spherical ball plus 4 all over 3 pi r cube for the second spherical ball that was melted, then plus 4 all over 3 pi r cube for the third. It's now going to be equal to same 4 all over 3 pi r cube for the latter spherical ball where they were poured into. So let's begin to substitute. The radius of the first spherical ball is 3 cm. So we substitute 3 here. You're going to have 4 pi times 3 cube all over 3 plus, here we have 4 pi times, the second one has radius of 4. So we have 4 cube all over 3 plus the third one, 4 pi arrow. The third one has radius of 5. So we have, instead of arrow, times 5 cube all over 3 is now equal to 4 pi arrow cube all over 3. Remember, it is this radius now that we are looking for. Let's simplify out 4 pi. Pi is 22 all over 7. So 22 divided by 7 is giving us 3.14285 blah blah blah. Then multiply it to 4 times 4 is giving us this. Then times, you know that 3 times 3 times 3 is 27. So we have times 27 is giving us, then divided by 3. Divided by 3. So all the thing we have in the first segment is giving us 113.1429 in 4 decimal places. Then plus, let's calculate this. First of all, 4 times 4 times 4 is 64. So let's start from the value of pi, which is 22 divided by 7 is giving us this, times 4 times 4 times 4 is 64. So times 64 is giving us the, then times 4 divided by 3. Here we are having 268.119 in 2 decimal places. Then plus 5 times 5 is 25. 25 times 5 will give you 125. So let's start from the value of pi. 22 divided by 7 has this value, times 125 has this value, times 4 we have this value, then divided by 3. Here we are having 523.8. Okay, let's say 81 in 2 decimal places. This is now equal to, what we're going to have here now is, let's start from pi. 22 divided by 7 has this value, times 4 we have this value, divided by 3. So we have 4.19. 4.19 arrow cube. Now the next thing is to sum up this so that we'll be able to begin to find the value of our R. Let's start from here. 113.1429 1429 plus 268.19 plus 523.81 is giving me 905.1429 is now equal to what we have here, 4.19 arrow cube. Now divide both sides by 4.19 so as to eliminate it as the coefficient of r cubed on the right hand side of the equation. So we're going to have 905.1429 divided by 4.19 will now give you r cubed. So let's divide out. 905.1429 divided by 4.19 is given me. So let's now have r cubed on the left hand side is now equal to 216.024. So let's leave it 216. If you take the cube root of both sides, you'll be left with only r on the left hand side of the equation, and on the right hand side you are going to have the cube root of 216. Let's take the cube root of 216. 216. Giving us, so we're going to have 6 centimeters as the radius of that spherical iron ball where the melted 3 spherical iron balls were poured into. But eventually you don't want to go through all this long process. There is a shortcut. If you look at this, when we are to sum the volumes of the 3 melted spherical iron balls and equate it to the later one that they were poured into, you kept seeing 4 all over 3 pi, 4 all over 3 pi, 4 all over 3 pi, 4 all over 3 pi. You can remove 4 all over 3 pi in all of them and equate r cubed, r cubed, r cubed, r cubed. What I mean is, you have something like this. Let's start here. R cubed for the first one plus r cubed for the second one plus r cubed for the third one is equal to r cubed for the later. The first r cubed will be 3 because the radius of the first is 3. So we have 3 cubed plus the second one is 4. 4 cubed plus the third one is 5. 5 cubed is equal to r cubed. 3 cubed is 27. 3 times 3 times 3. So we have 27 plus 4 cubed is 64. 4 times 4 times 4. 5 cubed is 125. You can cross-check all I'm saying with a calculator. I don't have the time. It's equal to r cubed. Now add up these things. You find out that you're going to get the same 216. 27 plus 64 plus 126. Sorry, 125. 216. So we have 216 is equal to r cubed. That means r will be the cube root of 216. Cube root of 216, which will give you the same 6 that we got when we used this long process method. At times, shortcut is very good and it conserves time. But in some cases, if you take shortcut, dog may bite you. We've migrated from the other topic to similar shapes. Now, in similar shapes, as a subtopic on our further mensuration, we want to do this equation. 2 similar triangles have their heights measuring 2 cm and 7 cm. Find the ratio of the ratio on which their area will be. At times, this kind of question is the type of question that students like some of you, let me not say you, will see on exam hall. It will be one of those questions they will keep and go to look for simpler ones without knowing that this one is the simplest that you could ever get. The two similar triangles have their heights measuring 2 cm and 7 cm. Now ask yourself, they now want the ratio of the area. Already, this 2 cm and 7 cm is already the ratio of the heights. Now, what they want you to change it to is area. If heights are in centimeters, I hope you know that area is a centimeter cube. Sorry, centimeter squared. How do you get centimeter squared from centimeters? You can only get centimeter squared from centimeters by multiplying centimeter by centimeter. That is the only way you can get centimeter squared. It's the only way you multiply centimeter to another centimeter. So simply, the ratio of their area is going to be multiplying the heights together and putting them as ratio. That's all. That means in this case, it's going to be 2 centimeter times 2 centimeter is to 7 centimeter times 7 centimeter. This is the only thing you do to get centimeter squared. There's no other thing you do. Now, 2 times 2 is 4. Centimeter times centimeter will give you centimeter squared. That means this has turned to area. Is to 7 times 7 is 49. Centimeter times centimeter will give you centimeter squared. The ratio, the question you're asking for, is 4 is to 49. You are done. This question number 2 is similar to question number 1. It says, I should calculate the ratio of the volumes of 2 similar cones of red dye of radar ratio 5 is to 3. In the former one, we talked about height and area. How do you get area from a height? You do it by multiplying height to height. Now, in the case of volume, before you can get a volume, you must have multiplied a particular red dye or a particular height by itself 3 times. That is why you always see the unit of volumes being in cubes, either centimeter or meter or kilometer cubes. So it's a very simple thing. If the red dye of the 2 similar cones are having the ratio of 5 is to 3, that means 5 centimeter or meter or kilometer, as the case may be, is to 3 centimeter. That is the ratio of their red dye. I've told you red dye is the plural of radius. Now, if you are talking of changing this ratio to volume, what you're going to do is 5 cm times 5 cm times 5 cm on one side of the ratio is now going to be on ratio with now 3 cm times 3 cm times 3 cm. This is the only thing you do to get cm cube, which is the unit of volume. 5 times 5 is 25 times 5 will give you 125. So we have 125 cm cube, because cm times cm times cm will give you cm cube. Is to 3 times 3 is 9, 9 times 3 is 27. So we have 27 cm cube. Cm times cm, cm squared times cm, cm cube. The required ratio now is 125 is to 27.